Hello everyone. Now we're going to solve some of the hardest paper 2 questions from Cambridge IGCSE Physics past year papers. The diagram shows compressions and rarefactions in air as a sound wave moves from left to right. A quieter sound of the same frequency is made. What will happen to the number of particles in a region of rarefaction and in a region of compression? Now, for a quieter sound, we know that the amplitude will be smaller, but the same frequency is going to be the same. It's going to be similar to this, right? So apparently, at the compression, the sound particles, they will be decreasing. So it's either C or A. And for particles in rarefaction, because the number of particles stays the same, it has to be constant. And in compression, it decreases. So in rarefaction, it would have to increase. So C. 33. Identical cells and identical resistors are used to make the circuits shown. In circuit 1, ammeter reads 2 amperes. What is the ammeter reading in circuit 2? Now you see that the number of cells also increase, and because this is connected in parallel, the resistance will be decreased. So let's just say this has 1 ohm, right? And this has the identical resistors, right? So this will have 1 ohm, 1 ohm. If you connect these two identical resistors in parallel, you will get this whole thing. It will have a resistance of 0.5 ohm. So basically, this is total is equal to 1 by 1 plus 1 by 1. So 1 by RT is equal to 2. So RT will be 1 by 2. So resistance will decrease by half. So the current according to V is equal to IR. When resistance decreases, current will increase. And because you have more voltage EMF as well, it will have the effect of 2 into 2. So we'll multiply 2 by 4, which is going to be 8D. The diagrams show a magnetized steel rod inside the solenoid connected to a potentiometer. In diagram 1, the potentiometer is connected to a DC power supply, and then in diagram 2, potentiometer is connected to an AC power supply. Which action would demagnetize the piece of steel? So for demagnetization, we're going to use alternating current, obviously, because we want to kind of mess up the orientations of the electrons inside the magnet. So we're going to need alternating current to do so. So if we want to decrease the current, then we have to make this arrow move to this side, because only then you will get smaller voltage from this source, and the current will be lower. So the answer will be S2RD. A driver sits in a car. She has a rear view plane mirror 0.5 meters in front of her. A bus is 7.5 meters behind the driver. The driver looks at the image of the bus in her mirror. How far is the image from her? So basically, the bus will be 8 meters behind the mirror, and because the driver is 0.5 meters behind the mirror, you will have to add another 0.5 meters for that. So the answer will be D. A concrete block falls vertically from an aeroplane. The concrete block falls into the sea and sinks. Which graph shows the vertical motion of the concrete block? So firstly, it falls vertically, which means every fall in the air, right, we have this general graph that looks like this. Because of air resistance, right, the acceleration would decrease. So the gradient would have to decrease. So you can cancel A and B. And it falls into the sea and then sink. So as it sinks, right, it will also reach a constant speed somewhere, right? So the question is whether it reaches this zero speed or not. When it sinks, right, will it actually stop in midway? You can consider dropping something into the water. It will not stop midway, right? It will reach a constant speed, and after some time, it will definitely not just stop midway if it's going to continue going down. So D cannot be the answer. So be C. A rocket is launched upwards from the surface of the moon. Hot gases are ejected downwards over a very short period of time. Which statement is not correct? Okay. So A, the rocket experiences a downward force. So you can see that it is launched upwards and the hot gases are ejected downwards, which means that it will experience this downward force from the hot gases. So it could be true. B, the rocket experiences an upward force while it's traveling upward. So yes. And C, the total momentum of the hot gases is equal to the momentum of the rocket. So momentum is a vector quantity, so you need to consider the direction. And the hot gases, they will have a momentum like downward direction, but for the rocket will be in upward direction. So this could be an answer. D, the total momentum of the hot gases and rocket when the hot gases have been ejected is 0. So yes, because as I mentioned, these C and D are contradicting each other. You can see that because one would be in negative direction and the other is plus direction, they have the same magnitude. So total momentum will be 0. So it is correct. So the statement that is incorrect will be C. The diagram shows a battery connected to a potential divider and to two lamps P and Q. The slider on the potential divider is moved from end X to end Y of the resistor. Which row shows the effect of the brightness on each lamp? Okay, so it will move from X to Y. And you can see that this whole thing is potentiometer, and this does not affect P because the current would be just going like this, right? It will just reach here to these two branches, and this Q will get from this branch. So this is one part. P is just there. So it'll be either C or D. Will not be changed no matter how you do this. So from X to Y, you can see that this will increase the length, it will increase the EMF gotten from this part, so Q will become brighter. See, a wire is moved across a magnetic field. This causes an induced current in the wire. The induced current interacts with the magnetic field to produce a force on the wire. In which direction is this force? So the movement, the direction of movement and the direction of force will have to be in opposite to each other. So the logic here is that because we see the induced current, we will use the right-hand rule from Fleming's right-hand rule. But to determine the movement of the wire motion, we will use the left-hand rule, right? So left and right, if you use different hands, when the direction of magnetic field and current is constant, then you will see that those two thumbs are in opposite direction to each other. So we have to choose D. A train is traveling horizontally in a straight line. A book is on a table in the train. The diagram shows all the forces acting on the book. How is the train moving? So firstly, we need to understand that the movement of train, the direction, and the movement of the book will be the same, similar to each other. And you can see that these three forces, they are not balanced, so they will have a resultant force, which means that it cannot be at uniform speed, so it's either A or B, right? So when we consider the direction of acceleration, we know that it is the same as the direction of resultant force. This is in Newton's second law, right? So because the frictional force, the resultant force, is to the right, then it will be accelerating to the right, B. A chef heats some water in a pan on a hot plate. The temperature of the water rises by 10 degrees Celsius in time t. She then puts the same volume of oil in an identical pan on the same hot plate. The specific heat capacity of water is 2.5 times that of oil, and water is 1.1 times denser than oil. What is the time for the temperature of the oil to rise by 10 degrees Celsius? So specific heat capacity. Before we know anything, we look at the related equations, right? C is equal to E by m delta T. So this T is temperature T, and we know we need the time T. So time T would be gotten by E is equal to PT, and we know that E will be directly proportional to T. So we just write the equation in E form so that it's easier to compare, right? So this is constant, and to change in temperature is constant, and mass specific capacity will be different, because mass will be different because it has different density but same volume. So we need to consider for the oil. And oil has 1 by 2.5 times less than water, because water is more, and it's 1 by 1.1 times of density, which means that so rho is equal to m by v, right? V is constant. So if density is lower for oil, then mass will be lower at the same volume. So the mass of the oil will be 1 by 1.1 of water, and specific capacity of oil will be 1 by 2.5 of water. So we just need this, right? So 1 by 1.1. So this is a ratio, and we just, so energy obtained will be this much of water. So because they're directly proportional to each other, you can just take the value of this. So if you put that in calculator, 1.1, 2.5, you will get 0.3636. So it'll be 8. The diagram shows a ray of light in an optical fiber. Which statement correctly explains the condition for the maximum transmission of light by the optical fiber? So it says maximum transmission, in a way like for maximum transmission you will need to have more reflections, right? This is quite intuitive. Rather than just having it like this, then with more obstacles, right, you will reflect more, and this will be more transmission rather than just one reflection. So when we do this, we actually slowing the light down, right, because of more curves. You have to reflect this way back. So that's why we have to choose from like C or D, because we have to slow the light as much as possible in this condition. This is slowing the light down. And to have more internal reflection, we need to make the critical angle small, so that we don't need a large angle for it to like internally totally reflect it, right? So critical angle small, so it'll be D. A car is driven from rest on a long straight road. The car engine exerts a constant driving force. The diagram shows the horizontal forces acting on the car. The resistive forces are proportional to the speed of the car. Why does the car eventually reach a maximum speed? So we need to know that maximum speed means constant speed is no longer accelerating to get to a larger speed, which means acceleration will be 0, right? So when acceleration is 0, this is because resistive forces will have to increase. So first, the driving force will be larger. This is resistive force, and then over time it will increase, so the acceleration will be 0, and you get to a maximum speed, D. A diode and a resistor connected across a variable DC supply. Terminal X is initially positive at a maximum value. The potential difference across XY is adjusted so that it changes as shown by the graph. Which graph shows how the current in the circuit from X to Y varies during the same time interval? Okay, so this is DC power supply, and you have to know that current flows from high to low potential. Obviously, this is quite intuitive, right? So when it does that, this diode is in wrong direction, which means that current cannot flow in this direction. So it will be like that, leaves us only one option, D. And for second part, you can see that it is adjusted, so that, which means at first, right, well, from X to Y, this X is larger, and after this part, obviously this is in opposite direction, so you can still travel like this, and that's why you have current in this direction. So the D. Each diagram shows 3 forces on a beam. In which situation is it possible for the 3 forces shown to be in equilibrium? Okay, so for something to be in equilibrium, we know 2 conditions, right? The resultant force is 0 and resultant moment is 0. So for A, first force could be 0, but for moment you can see that only for this one side it is putting force downwards, so may not be true. For B, it's clearly we're going to rotate in this direction, and for C as well, it will be rotating in this direction. So for D, you know that some of the forces could be 0, and for a moment, and these 2 forces, upward forces, will make it go upwards, but this is going to make it go downwards. So it's going to be going to cancel each other out. So D is more sensible than 2 forces concentrated on one side. So be D. Here are 4 statements about wavefronts. Wavefronts from, okay, so they're asking about correct statements. Wavefronts from a point source are straight lines. This is not true because it's from a point source. You can imagine like dropping something in the water, like a small thing, like a rock. You would see that the wavefronts, they will not be straight. They will be like kind of circular waves like this. So yeah, wavefronts from point source are circular. Wavefronts are parallel to the direction of energy movement. So no matter whether it's transverse or longitudinal, they have this general shape of wave, and wavefront will always be like perpendicular to the direction of the movement. So it will be 4. 2 and 4 will be D. 4 people of equal weight on beach use different routes to get to the top of a seawall. Which person produces the greatest average power? So power is equal to energy, P is equal to E by T, right? So we know that we have to consider the lowest time taken. And for energy, it doesn't matter which route you take. In the end, like, you will have gained the same amount of energy. So it only depends on time. So it will be C. So the reason why the route taken isn't important is that at the end of the day you will reach a certain point, right? This is the certain point that you will reach. So after all, you will gain some amount of GPE, and this is the work done. It will have to be done the same amount of gravitational potential energy. So yeah, it also says equal weight. So okay. A heavy truck on wheels has a platform attached to it. A man stands on the platform. The truck does not fall over. Which position A, B, C, or D could be the center of mass of the whole system? Truck, platform, and man. So we have to consider like point of pivot, right? The moment that could happen. And from that point, we will know that the moment provided by this man will have to be equal to moment provided by the center of mass of the track. So you can just have a goal, like this man is standing over here, so it could not be this close to here. Man is not that heavy, and A is just out of the thing, so it's either B or C, and C is kind of close, and it's a small region right here, so more sensible answer would be B.